Welcome back, chemistry fans. Today we're going to do part 2 of our new unit 6, topic 1. I decided to spread this out over 2 nights. And so if you've already done this one particular problem, then you are finished with your homework. But let's just jump into this one particular problem in case you did not do it the last time. So maybe ahead and maybe not. You may have no homework tonight. That's good news. Okay, so I'm going to share with you this one particular problem. Okay, they want us to draw, I want you to draw a Lewis structure for SO3. One of the first pieces of information you have to understand about Lewis structure is that the first element is always the center of symmetry. The only time where this doesn't happen is whenever it starts with hydrogen. Hydrogen will not be able to be in the middle because it only wants one bond. It wants a stable duet. Everyone else is going to want a stable octet. Okay, so I'm going to surround this with oxygens. You could have just as easily have drawn your oxygen at the top and left one of the sides or the bottom empty. It doesn't matter. I'm just choosing to make it symmetry as best I can this way. Now, I know that I have 6 valence electrons for each, the sulfurs and the oxygen. So I could just hem-haw and I could guess where the locations of the electrons belong. Or what I'm hoping you will start doing is use want minus have for your directive. So want is the fact that every atom wants 6 valence electrons. I'm sorry, every atom wants 8 valence electrons. So there are 4 atoms, they each want 8. That is a total of 32. So this guy wants 8, he wants 8, he wants 8, and he wants 8. So 8 plus 8 plus 8 plus 8, that is 32. Yeah. Now, how many they have is a different matter because they each are born with 6 valence electrons. You're saying, well, how do I know that? So let's jump onto a periodic table and let's find out where it is on the periodic table. It's over here, the sulfurs and the oxygens are. So if I count my valence electrons, they both have 6. So that's how I knew that they had 6 valence electrons moving forward. Okay, so 4 atoms, they each have 6. That is a total of 24. The difference between those, I subtract those and I get 8. Okay, now what I need you to do next is to divide that number by 2. And this tells you the number of bonds because every bond is made up of 2 electrons. And if you connect them, it makes into a bond. So I know that I'm going to have 4 bonds, but I've got only 3 locations that they could be in. So that means it's going to have to be unsymmetrical, maybe at best. But it's a structure that we call resonance, where the bonds are moving from one location to the next. So the best way that we could do to make this look symmetrical is, first off, though, give everyone a single bond. Now you're saying, what do you mean give everyone a single bond? Well, I could put 1, 2, 3, 4, 5, 6 electrons in here. I know that I'm going to have 8 in here. So that means someone is going to get a double bond somewhere. So I could add 2 more, connect those, and again, I would have a double bond just in this one location. So I'm going to have a double bond on one, and I'm going to have singles in the other 2 locations. Now, you are saying, well, what if I want to put it over here? Well, that's perfectly fine. You can do that. That is a choice. It doesn't change how we solve this problem. It's just a temporary movement of the electrons. So it is just as correct for you to have them in a different location as to where I'm choosing to put them. So I have used up now all of my 8 electrons that are in the bond. I have created 4 bonds. Now I don't have a stable octet on all of these atoms. So now I got to go and fill in the rest of my 24. So if I had 24 electrons to start and I've used up 8, that means I have 16 more that I need to place out here. Well, looking at the sulfur, it already has its stable octet, because if you count all the electrons in the bond, that's a stable octet. But the sulfurs on the bottom, I'm sorry, the oxygen on the bottom, it only has 4 electrons, so it will need 4 more. 5, 6, 7, and 8. So I can subtract that now from over here. I've added 4 more, so I'm down to 12. The oxygens on the left and the right, they need 6. 1, 2, 3, 4, 5, 6 before they have a stable octet. 1, 2, 3, 4, 5, 6. Now, if I look around here, I just added 12 more electrons. That means I've used all of my electrons, and this oxygen has a stable octet. This oxygen has a stable octet, and my oxygen down on the bottom has a stable octet. Everyone got their stable octet. We showed our work, and we got it drawn as a correct Lewis structure. So this is everything that I wish to share with you today about Lewis structures. If you can handle this one problem, you can do any problem I give you. Thank you so much. I will talk with you again soon. Farewell.